Right, coordinate proofs. Coordinate proofs we graph figures in a coordinate plane and then use the coordinates of the figures to draw conclusions regarding all other figures of that type. So we're going to go ahead and graph different coordinates in the coordinate plane, and those coordinates are going to look a little different because they're not going to be numeric values per se. So first thing we need to do is review some of the useful formulas we have here, and these formulas are mostly from algebra here. We have the slope formula. So slope m is equal to y2 minus y1 over x2 minus x1. And I guess I should preface this with if we're given 2 points, and let's call those points x1, y1, so 2 coordinates, and x2, y2. So using those 2 coordinates, we can find the slope using this formula. Find the distance using the distance formula. Distance formula is just a variation of the Pythagorean theorem, but x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And then the midpoint formula, and I'm just going to use MD for midpoint. The midpoint is a coordinate. It's the midpoint of a line. So x2 plus x1. So really we're taking we're taking the average of our 2 x values and then dividing it by 2, and then y2 minus y1, plus y1, and dividing that by 2. So we have the distance formula, the midpoint formula, and the slope formula there. So using those formulas, what we're going to do is we're going to start by, well, actually, before we use those formulas, we're going to find some different points. Now, so it's finding coordinates for points. Give the coordinates of point A and B without using any new variables. So note that they have the variables RT given. And just a quick reminder, like when you're plotting a point, like if we're plotting this coordinate right here, and let's say it was the ordered pair. I know it says RT, but let's pretend for a minute it said 3, 2. Really what we'd do is we'd start at the origin 0, 0, which is where C is. We'd move over 3 units. This would be 3 here. And then we'd go up 2 units. So this would be 2 here. Okay, oops, I'm supposed to hit a B there. And that would be the ordered pair 3, 2. So we go to the right 3 and up 2. Since we go to the right, we're going positive. Since we go up, we're going positive. Okay. Well, it's not saying that. It's actually saying we're moving RT. Okay. But the same idea applies. We're moving R units to the right. So this would be R. And we're moving T units up. So this would be T. And that's RT. Well, why is that helpful? Well, because that allows us to find point A. Point A means from the origin, we move R units over. So that's R. And we don't go up and down at all. So that's 0. And point T, or excuse me, point B, we don't actually move left or right at all. So we move 0 left to right. That means on the x-axis. But we move up T units on the y-axis. So that's 0T. Now what it asks is give the coordinates A and B without using any new variables. Then find the coordinates of the midpoint of AB and the length of AB. So the next piece would actually be to find the length and the midpoint of AB. Now I'm going to actually find AB on all of these shapes first, and then I'm going to come back and find the midpoint and the length. But just so I'm going to make this a little cleaner because I know I'm going to have to use a lot of space here in a minute. Just so we're clear, this was a rectangle, meaning all sides are congruent. This next one's a square, meaning this side's congruent to this side, and so on. And that's helpful in this next shape because if I'm finding B and point A, well, I know to get to 0T, I have to move left and right, nothing at all from the origin. So but I am moving up T units. And if it's a square, all sides are equal. So that's T, and that's T. All of these are T. That means to get to point A, I move left or right T units, and I move up 0 units. And to get to point B, I move right T units, and then I go up T units. All right. And on this one, we also have a square. Note that This point is RR, which means I move to the right R units, and then I go up R units. Okay, so all of these are R's here, and I go right R units and then down R units to get here. So we have a bunch of R's, okay? And if this is R, well, and this is R, this is also going to be R here. And this is 2R, so this has to be R, and this has to be R to make it 2R. So I would move an awful lot of R's here, so let's simplify this just a bit. Okay. So I know this is R and this is R, which means this has to be R and this has to be R because it's a square. Opposite sides are congruent. I also know that this is R and this is R. So this R, this R, excuse me, I guess I know those two are R. So this has to be R and this has to be R. So I move R units to the left, which is negative R, to get to A, and then I move R units down, which is also negative R. And to get to B, I move R units to the left, which is negative R, but then I go up R units, which is R. Okay. So the next part is to find point A and B, or excuse me, to find the midpoint of AB. Well, this first shape, let me go ahead and switch colors here. The first shape, you'll go, well, I don't even see a length from A to B. Well, that just means you have to draw it in. There's AB right there. And to find the midpoint, there's two ways to do it. One's to use the formula, which is what I'm going to do first. And then the other is to kind of use an intuitive process, which I'll also do on some of these others. But on this one here, if I want to find the midpoint, I am going to use the midpoint formula. And the midpoint is going to be equal to x2 minus x1. And so I usually read from left to right. That way I just remember that this is I'm going x2 minus x1 and then y2 minus y1. The important thing is that if you're calling this x2 and this y2, and if this is x1, this one has to be y1. Okay, so the 2's have to go together and the 1's have to go together. I generally just go left to right, and therefore it helps me to just remember I'm going 0 minus r, or I guess in midpoint formula I'm going 0 plus r, and then dividing by 2. And then t plus 0 divided by 2. Now in the midpoint formula it really doesn't matter because you're adding and you can add in any order, but try to follow the formula. It gives me r over 2 and t over 2. Now that's kind of the mathematical approach. Intuitively that makes sense, right? Because really if this whole length is r, well half of that length would be r over 2, and I'm trying to find that point, so that'd be r over 2. And if this whole length is t, well, half of that length would be t over 2. And so that's the coordinate r over 2, t over 2. That's what it's saying. Okay. And this one, if I'm finding the midpoint, well, this one's a little easier. I mean, it's a vertical, straight vertical line. If they're vertical or horizontal lines, rather than diagonal, it's a lot easier. So I could use the midpoint formula, but I could also look at it and go, well, I know to get to this point right here, and actually let's erase that t. Okay. To get to that point right there, I move over t units, and then I have to go up half of this whole length, which is t over 2. So that's a lot easier to find the midpoint that way. That's more of an intuitive approach, and that's okay to use as well. On this one, well, the midpoint is right there. Well, I move over r units to the left, so that's negative r, and then I don't move up or down at all, so that's 0. Okay, so we have our midpoints here, here, and here. Okay, now to find the length of AB, let's go ahead and switch up colors again. Okay, length I have to use the distance formula, and so what I'm going to do is go d is equal to, and once again I'm going to think moving from left to right. So 0 minus r, quantity squared, plus t minus 0, quantity squared. Okay, well what that gives me is negative r. Now don't forget that's still in parentheses because we're squaring it, and that's important. And then t squared. Okay, well negative r squared is negative times negative, which is positive. So I have the square root of r squared and then t squared. I could just drop the parentheses there. Okay, that is my distance. On a vertical line, it's a lot easier, right? We already know the length of this line. The length was t. So distance equals t. Now you could go through the formula, but you're going to get t. You could still use these points. And here it's also vertical. So the length is, well, 1r, 2r. So my distance is 2r. And once again, you could use x1, y1, x2, y2 if you wanted and calculate it, but you get 2r. All right, let's go ahead and move on. Let's try some others here. Okay, so we have a parallelogram this time, and same directions. So we got to find point A and point B first. So I'm going to switch back to my original color. And I am going to point out that to get from our origin, 0, 0 right here, out to this point right here, which has a length of d, okay, we obviously move d units out. Well, they give us another point. They give us this one right here. Okay, and I'm going to dash that down. To get to that point, I'd have to, it's saying that has a length of d minus r. So I have to go out d units. Okay, and let me go ahead and switch up some colors here. To go out d units, so I'm going to go this far. Okay, but then I'm going to drop back in r units. So I'm going to go back this way. Okay, so I'm going to go back that way, r units. So I'm d, and then I'm subtracting r. So this is d minus r. Well, that means this little chunk right here, or this little piece right here, is r. And that's important because if I were to draw that same triangle up here, that is the same length as that in a parallelogram. These little triangles are congruent. We could go through a proof on that, but those triangles are congruent, which means this little chunk is r, which means this little chunk is r, which means point A is at r, comma, 0. All that to get point A. And point B is a lot easier. We just don't move left or right at all. Okay, so we go 0, but then we go up t units. So that's 0t. Okay, and these others are a lot easier. I mean, this is a rhombus. All sides are congruent on a rhombus. Meaning if I move out r units that way, I have to go r units this way. So this is at negative r and 0. If I go t units up, that means I'm going to go down t units. So this is going to be 0, negative t. And an isosceles trapezoid, if I move r units this way, I'm going to go r units this way. I move t units this way, I'm going to go t units this way. Okay, so isosceles trapezoid, remember these sides are congruent. All right, so if this is the ordered pair TD, this is going to be the ordered pair negative t, because I'm moving t units to the left and then still at the same y level of d. And point B, we're just moving 0, but then we're moving up d units, so 0d. Remember, I know that's d because that's my y value right here, so I have to go up d units. Okay, so to find the midpoints, let's switch our colors here again. To find the midpoints of AB, the midpoint is right there. Okay, and to find the midpoint, I'm going to use my values and my midpoint formula. So midpoint formula is going to be 0 plus r over 2 and t plus 0 over 2. Oops. Now notice once again, I just went from left to right when reading my graph. That way I didn't have to really label my points. But if you wanted to, you could call, well, it's x2, y2, and x1, y1. Okay, that's all I did there. It gets kind of really messy when I go with that. But okay, and that gives me a midpoint of r over 2 and t over 2. Notice they're both positive coordinates and they're both in the positive quadrant there. Okay, so there's my midpoint. On this one, the midpoint, well, if we call negative r plus 0 over 2 and 0 plus negative t over 2. Usually put that negative in parentheses just to separate the positive and negative. So that gives me negative r over 2 and negative t over 2. And note that those are both negatives, and this is in the negative coordinate, or quadrant, excuse me. Okay, and then the midpoint here, A little easier, right? I mean, if this length is t, well, halfway, go ahead and erase that for a minute. We're finding the midpoint. That's right there. It's a horizontal line. So really, if that whole length is t, that's got to be t over 2. So we're going t over 2 to the left and then up d. So the midpoint is going to be t over 2 to the left, so that's negative, and then up d. Right there. Now the distance. Okay, well, the distance. Let's go ahead and switch up colors real quick again. Distance formula. Whoops. All right, let's see if I can, there we go. D is equal to the square root of, well, 0 minus r squared, quantity squared, plus t minus 0 squared. Okay, so that's going to be the square root of negative r squared plus t squared, which is square root of r squared plus t squared. Remember, negative squared is the positive. We got it. For our rhombus here, well, the distance, negative r plus 0. So negative r plus 0 squared plus 0. Excuse me, that is not plus 0, that is minus 0. Sorry. 0 minus negative t squared. Should have two sets of parentheses there. All right, and so that distance is, that is negative r squared plus negative and negative is positive, t squared, which gives me r squared t squared plus t squared. They're not always going to be the same distances, but in that case they are. This is a horizontal line. We already know this distance. It was length t. The distance here is t. All right. Well, we've dealt with some lengths and some midpoints, some distances there, and finding coordinates. Let's go ahead and deal with some slopes. All right, remember the slope formula. Let's rewrite that up here. So that is y2 minus y1 over x2 minus x1. Remember, that's the differences of your y, your change in y over change in x. So if we're dealing with wx, notice wx is a flat line here, the slope of wx. So we've got a flat line. Remember, a flat line, if you recall, has 0 slope. Okay, and if you were to apply your formula, I'll just do this once here. So we got x2, y2, x1, y1. Okay, in this point, so y2 would be a minus a. y2 minus y1, so a minus a. And then x2 minus x1, so 0 minus 3b. Okay, well, notice on the top you get 0. And it really doesn't matter what you get on the bottom because anything divided by 0 is 0. So flat line, 0 slope. In fact, zy, or yz, this one right here, is also a flat line. And a flat line, you don't even have to do the calculation. It has 0 slope. Okay, well, that's different than, say, like these slanted lines. Okay, please recall that a line that falls from left to right has a negative slope. A line that rises from left to right has a positive slope. A line that is flat has 0 slope. And a line that is vertical has undefined slope. Okay, so just a quick reminder there in terms of our slopes. Well, if I'm dealing with xy, I'm going here, and I'm going to read from left to right again. So it's going to be my x2, y2, and here will be my x1, y1. Okay, so I won't always label those, but 0 minus 3b. Actually, let me show one other thing. I'm going to show two different ways that I've seen this done. Okay, so you have your 4 spots, your y2, your y1, your x2 minus x1. So I've got my 4 spots. So 0 and 3b, those are my x's. And 0 and a, those are my y's. So I just fill in like places on a ride, right? Little seats for the letters there. That gives me negative a over negative 3b. And negative divided by negative is positive, so I get a over 3b. And notice it's a positive slope. Okay, so this better be a positive slope. Good. The other way I've seen this done, we'll do it with ZW here. So let me go ahead and erase these. We're going to call this x2, y2, and x1, y1, because I'm going to go from left to right. Okay, and so just so if you were to print the notes, you don't get confused there, we've got those erased. But the guy I teach with, Mr. Vogel, what he does is he takes, and he likes to say, well, I know the first one is y2 over x2. So if I think of it like a fraction, okay, and I have two fractions that I'm dealing with, okay, so I have my minuses, and I could say, well, 0 over a. And I'm sorry, I just messed that up. I don't use this method tons, but so that's my excuse. But it'd be 0 over negative b. So you take the coordinate and then 0, or a over 0. Take the coordinate and just kind of flip it, okay, into a fraction. So this coordinate would become like a over 0. If I could draw a 0. And this coordinate would be like 0 over negative b. Okay, that's kind of what I have here. That's a nice way to do it. It gives me negative a over negative b. Negative divided by negative is a positive, so we get a over b. And it should be a positive slope. There we go. We've dealt with the slope formula, midpoint formula, and distance formula. That allows us to be ready to do a actual proof. So I have two proofs we're going to do. Okay? All right, so let's go ahead and look at this. And when you're doing a coordinate proof, you're really doing more of the bulleted list. You're not doing like a paragraph proof or anything. So given ABC is a right angle, so this angle is a right angle, and T is the midpoint of AC, prove AT congruent to TC congruent to BT. So there are a couple ways to do this. First one I like to think of is, since they tell me that T is the midpoint, first thing I'm going to do, and even if they didn't tell me that, I'm just going to find all the other coordinates. Now I'm going to easily write in 0, 0 for B. Okay, but I'm just going to kind of make a list of what I'm doing. So first thing is use the midpoint formula to find the coordinates of T. And hopefully I can set my hand on this without actually adjusting it every time. Okay. Use the midpoint formula to find the coordinates of T. And I'm just going to actually show that work right here. So that's going to be 0 plus 2e over 2 and 2g plus 0 over 2. And when we simplify that, that just gives me 2e over 2 and 2g over 2, which is the same thing as the 2's cancel. So we get EG. Okay, so this coordinate is EG. That was my first step, and I just showed my work with it right there. I'm now going to use the midpoint formula to show that AT is congruent to BT. I already know that AT and TC are congruent. I know that's congruent by definition of midpoints, right? So all I need to prove is either AT is congruent to BT or that TC is congruent to BT by using the distance formula. So I'm just going to use AT congruent to TB or BT, okay? So the next step, use the distance formula to find the lengths of AT and BT. Okay, and so AT is going to be equal to the square root of, well, so from A to T, 0 minus E squared plus 2G minus G, quantity squared, which is square root of negative E squared plus g squared, which simplifies to the square root of e squared plus g squared. All right, so we found one distance. So it's important that, oops, that's not a, that's at, sorry. It's important that now that bt has that same distance, so we double check that here, okay? So bt, we're going to go 0 minus e squared plus 0 minus g squared, which ends up giving us negative e squared plus negative g squared, which is squared e squared plus g squared. Hey, they're the same. We already know that at equals tc by definition of midpoint. So we have all of our pieces in place. The final thing is to actually just write a quick summary. Okay. So AT equals TC, which equals BT, which is what they asked us to prove, right? Because AT and, oops, sorry about that, and BT measure, and we're going to actually use measurements to help with our proof, and AT equals TC by definition of midpoint. All right. There we got it. Just make sure you have the math behind you and you're showing your work. Okay. Very last one here. All right, we're given trapezoid ABCD. AB is congruent to DC. X, Y, and Z are midpoints. We want to prove that X, Y, Z, so this inside shape here, is a rhombus, meaning prove that all sides are congruent. So I guess the first part is to find, well, I'm going to find points A, B, A, and B. Okay. So find the coordinates of A, and A is, well, if this is 2E here, this length has to be 2E, okay, because it's an isosceles, or it's a trapezoid there, and AB is congruent to CD, so technically it's an isosceles trapezoid, so this length has to be equal to this length, okay, that's 2E, so A is at negative 2E, 0. I'm just going to list that here. And B, if this is, well, to get to point C, you have to go over 2F and up 2G, so that's 2F, meaning this is 2F. Oops, hand slip there, 2F. So we go left 2F and up 2G, so it's negative 2F and 2G. Okay? Oops. Let me pause. Okay, I'm back. And it switched colors on this, so let me fix my color. Okay. So, and the reason I put those first is because really to find those points versus W, X, Y, and Z. W, X, Y, and Z, I'm going to use the midpoint formula for a couple of them, but A and B I'm not. In fact, I can also find X and Z pretty easy, right? Because I don't even have to use a midpoint formula. So let's go ahead and do that. So I'm just finding all the missing coordinates right now. So X X is going to be, well, if we're at 2G, so this length is 2G, we don't move anywhere left or right, so it's at 0. But we go up 2G, so it's at 0, 2G. And Z is just at the origin. Okay, that makes that one real easy. You could use the midpoint formulas, but that's pretty easy with that one. Okay, however, sorry about that. To find WY, we're going to use the midpoint formula. Okay, so W is going to be equal to, let's go 0 minus 2E Actually, I'm sorry. Stick with my rules kind of here. I picked the wrong point here. So negative 2E or plus negative 2F. Okay. Over 2. So we're going A to B. And then 0 plus 2G over 2. Okay. And so that's going to give us negative 2E minus 2F over 2 and 2G over 2. And in terms of this, we can actually cancel the 2's. There, and then cancel those. So since both the top and bottom have, it's like factoring out a 2. So we get negative E minus F, not over 2. So let me actually take up the whole space. And G. Now that is a weird midpoint. However, that is it. Negative E minus F, G. That is coordinate of W. And then Y. Y is going to be 2F plus 2E over 2 and 2G plus 0 over 2. Note the similarities. It should be the same Y value because it's directly across. Okay, so we get, excuse me here, we cancel our 2's. So we get F plus E and G. Okay. All right. I know sometimes my E's are looking like C's there. There we go. Okay. Well, I know all my coordinates now. I guess the next piece would actually be to show that WX, XY, YZ, and WZ have the same length. So using the distance formula there. Okay. So I'm going to go ahead and switch up color. And we're going to say use the distance formula to find the length of AT. Oops, excuse me, not AT. Actually, you know what? Because I'm going to find the length of WX. Let's start with that. Okay. And so for WX, we're going to go, since I have all these negatives here, I'm going to start with the 0 this time. Okay. So, because I'm subtracting. So 0 minus and E minus F, quantity squared. So this is my X2 and my Y2 on this one. This is my X1 and my Y1. Okay. Plus and 2G minus G squared. Okay, well, what does that give me? Well, that gives me, notice I have to distribute this negative. So I end up with quantity negative E I mess up? Oh, I forgot a negative here. Fix that. My apologies. Should have been negative E, negative F, so I end up with positive E right here. So I end up with E plus F, quantity squared. So I distribute that negative, plus, well, that's G squared. And I can't simplify that anymore, so I am done. Okay, well, let's go to XY. XY, start here, we'll call this one X1 this time. Okay, so we have 0, 0 minus F plus E squared, and then plus 2G minus G squared ends up being negative F minus E squared plus G squared, and the two negatives, that ends up, when we're squaring it, it ends up becoming F plus E squared G squared. Well, F plus E G squared is the same as E plus F quantity squared. Let's make them all look the same here. E plus F squared plus G squared. All right. Well, that happens to be the same as what I have on this previous one here. Very good. So far so good. Let's go with ZY now. ZY is a lot easier because you have a 0 in there. So we have, I'm going to go okay. So I have 0 minus F plus E squared plus 0 minus G squared. And you'll notice after the first step here, distribute that negative, I end up with negative F minus E squared plus G squared. Well, or negative G squared, I guess. That is identical, or very similar, to what I just had. So this becomes, once again, F plus E squared, and negative G squared is G squared, and that is E plus F squared plus G squared. So far, so good. Okay, last one, WZ. WZ, well, we have 0 minus negative E minus F squared plus 0 minus G squared, which is, well, that negative gets distributed again, so we get E plus F squared plus negative G squared, which is equal to E plus F squared plus G squared, which is the same. Therefore, we can finish it up. Let me write it out. Actually, let's go to a brand new color here. Since Wx equals xy, which equals yz, which equals wz, which equals the square root of E plus F squared plus G squared, kind of running out of space. I'm sorry. W, X, Y, Z is a rhombus by definition. There we have it. That is quite the proof. All right, well, that's all I got for you, I think. Yep, good lucky.